Hey guys, welcome again. Now we would be talking about deploying pods from a manifest file. So if you are following along with the example, save the following manifest file as pod.yml in your current directory, as you can see on the screen right now. Use the following kubectl1 command to post the manifest to the API server and deploy a pod from it. Here it is, you can see this here. Although the pod is showing as created, it might not be fully deployed on the cluster yet. This is because it can take time to pull the required image and start the container. So run a kubectl1 get pods command to check the status, which we have done it here. We can see the container is still being created, no doubt waiting for the image to be pulled from Docker's hub. You can use the kubectl1 describe pods hello pod command to drill into more detail. If you run the kubectl1 get pods command again, after a short wait, you should see the status as running. So you'll see this. Okay, so congratulations, your pod has been scheduled on a healthy node in the cluster and is being monitored by the local kubelet process on the node. The kubelet process is the Kubernetes agent running on the node. Now let's talk about, or let's introspect running pods. As good as the kubectl1 get pods command is, it is bit light on detail. Not to worry though, there is plenty of options for deeper introspections. Let's take a look at some. First up, kubectl1 get offer a couple of really simple flags that give you more information. The -o white flag gives a couple more columns, but is still a single line of output. The -o yam1 and -o json flags take things to the next level. Both return full copies of the pod manifest from the cluster store. The command below shows a snipped version of a kubectl1 get pods -o json command, as you can see on the screen. And let me complete the command. Let me quickly go to the next screen. If you have taken a note of these codes, 1 second. Yeah, here it is. So now notice how the output above contain more values that we initially set in our 13-line YAML file. Where does this extra information come from? So two main sources. One, the Kubernetes pod object contains a lot of properties, far more than we defined in the manifest. Those that we don't specify are automatically expanded with default values by Kubernetes. Point number two, when you run a kubectl1 get pods with -o yam1 and -o json command, you get the pod's current state as well as its desired state. However, when you define a pod in a manifest file, you only declare the desired state. So another great Kubernetes introspection command is kubectl1 describe. This provides a nicely formatted multi-line overview of the pod. It even includes some important pod lifecycle related events. The following command describes the state of the hello pod and shows a snipped output, as you can see in the screen. Yeah, you can see in the screen. Okay, so the output above has been snipped to better fit the page. Another way to introspect a running pod is to log into it or execute commands in it. We do this with a Kubernetes-1.18 exec command, execute command. The example below shows how to execute a psaux command in a first container in the hello pod state. This you can see here. Yes, you can log into the first container in the pod with the following command. Once inside the container, you can execute normal commands. As long as the command binaries are installed in the container, the Kubernetes-1.exec command will log into the first container in the pod and create a new shell session. Once inside the container, the cur1 command transfers data from the service listening on port 8080, as you can see here. The -it flags make the executive session interactive and connect stdin and stdout on your terminal windows with stdin and stdout inside the container. When the command completes, your shell prompt will change, indicating that your shell is now connected to the container. If you are running multi-container pods, you will need to pass the Kubernetes-1 execute command the container flag and give it the name of the container in the pod that you want to create the exec session with. If you do not specify this flag, the command will execute against the first container in the pod. You can see the ordering and names of containers in pod with the Kubernetes-1 describe pods command. One other command for introspecting pods is the Kubernetes-1 logs command. Like other pod related commands, if you don't specify a container by name, it will execute against the first container in the pod. The format of the command is Kubernetes-1 logs. So let me quickly summarize what all things we covered in the last few chapters. So we learned, or the lectures, we learned that the atomic unit of deployment in the Kubernetes world is the pod. Each pod consists of one or more containers and gets deployed to a single node in the cluster. The deployment operation is an all or nothing atomic transaction. The best way to deploy a pod is declaratively using YAML or JSON manifest file. We use the Kubernetes-1 command to post the manifest to API server. It gets stored in the cluster store and converted into pod spec that gets scheduled onto healthy cluster node with enough available resources. The node or minion component that accepts the pod spec is the kubelet. This is the main Kubernetes agent running on each node in the cluster. It takes the pod spec and is responsible for pulling all images and starting all containers in the pod. If a pod fails, it is not automatically rescheduled. Because of this, we usually deploy them via higher level constructs such as replica sets, deployments, and daemon sets. These higher level constructs add things like self-healing and rollbacks and are at the heart of what makes Kubernetes so popular, famous because of the good, powerful features. So that's it for this lecture. We will proceed with other fresh Kubernetes detailed topic in the next lecture. Thank you very much.